Okay, so the first part of today is an application. So sine and cosine functions, they can be used to model real world situations like sound waves. And frequency is one way that we can do this. So frequency is the number of cycles in a given unit of time. Okay? Frequency is the number of cycles in a given unit of time. Remember yesterday we talked about the period of a function. Okay, so the period is one cycle. Okay, so to find the frequency, you can just take the reciprocal of the period. And then hertz is the standard measure of frequency, and that's 1 cycle per second. So I'm not sure if in science class you guys have ever, if your teachers ever showed you a tuning fork, but it makes a sound wave. And it has a frequency of 440 hertz. This means that the wave repeats 440 times in a second. So we're going to use the sine function to graph a sound wave, and then I also am going to show you guys. Remember yesterday we graphed the sine. Okay, so we started at 0, 0. We looked at this one wave for sine, okay, but really this continues forever, right? Do you guys remember how this number in front of x affects the graph? Horizontally. Yep, horizontally, the period. So if I change this to an 8, look what happens. Okay, the period changes, which means the number of cycles increases. Okay, but if I made it into like a 0.5, then it gets stretched out, so you don't have that full cycle there. Okay, we also talked about the cosine. Okay, so if you have y equals the cosine of x, all right, look, don't these look very similar to each other? Yeah. Okay, they really are the same, they just have different starting places. So later today we're going to learn about what's called a phase shift. So if I were to take my cosine graph and shift it over, look what happens. They're the same. They overlap, right? You can also shift it other ways so that they don't overlap, but it will make a difference there. Okay, so we're going to look at that today as well. Alright, so when we're using the sine function, they give you the period, they give you an amplitude. We're going to find the frequency in hertz for the sound wave. Okay, this is something you could do with or without a calculator. Good, so you guys set up your first equation. So if you have not yet, I want you to find the frequency. So use it, the frequency equals 1 over p. Okay, you can see that I've boxed in a few things to help me. So I know that it's a sine function. Okay, I'm given the period. And I'm given the amplitude. Okay, what we have to find is the frequency in hertz for the sound wave. So for the first one, we have frequency is 1 over the period, right? So we put 1 over what? 0.002. Yes. Okay, so if we did that with our calculator, it would be really, really simple. But really, what place is this in? Thousandths. So this would be 2 over 1,000, right? What is 2 over 1,000 reduced to? 1 over 500. Okay, so this is 1 divided by 1 over 500. So if I keep change flip, I get 500 hertz. Okay, questions for me on that part? Finding the frequency when you have the period. Okay, now we are going to graph. Notice that we're doing this without a equation. function, but we don't even need it, alright? So it says we're using a horizontal scale where 1 unit represents 0.002 seconds to complete 1 full cycle. They're just reminding you that the 0.002 seconds is the period, that is your cycle. And then the max and the minimum values are given by the amplitude. So what is our amplitude for this? 3. Okay, so if our amplitude is 3, then our max is what? Our max is 3, and our min is -3. Okay, so we talked about that yesterday. Okay, we also talked about a good way to pick a scale yesterday. Do you guys remember what I told you? For the scale, a good way to find a scale for your x-axis? You take the no, but you take the period over 4. So if you take the period, which is 0.002, and you divide that by 4, okay, you guys can check that too on your calculator if you have that handy. Okay, so yesterday we talked about how you do the period over 4. So if we did 0.002 over 4, what do you guys get in your calculator? What do you get? Yeah, it says 5e, right? It says 5e to the -4. So, do we understand that 5e to the -4 means 5 times 10 to the -4? What does that look like as a number?
0.0005.
So if you start here, right? 1, 2, 3, 4, you have 3 zeros, right? Okay, so technically that is going to be our scale, but when we label this, we're going to go 0.001, 0.002, 0.003, 0.004, and then anytime you are doing an application problem, so a real world problem, you only have to do the positive side. Okay, so only graph positive side for real world models. No, well, and I'll show you that. Okay, so this means that this here, this is your 0.0005. Okay, if you add 0.0005 to 0.0005, you get 0.0010. Right? Because it would be 10, like the 5 and the 5 carries over into the next place. Right? So with every unit, if you went by that, 0.005 plus 0.005, see, you get 0.001. Okay? Okay, and it's kind of like this is a half, right? We just have to have the extra 0 in there because we're doing the division. Okay? Alright, now that we've set that up, we're going to use the same patterns from yesterday. Okay? So let's just review the sign of x real quick, okay? So we did work with the sign of x yesterday. We started at 0, right? Where did we end? We ended at 0, and this was the, whatever the period was. You started at 0, you ended the period, which is going to be 0. So we have 0, 0, period 0. What happened halfway? Halfway was 0. And this is for sine, because remember, something different happens for cosine. And then halfway in between the start and half, you reached your maximum. Okay, and then halfway between half and the end, you reached your minimum. And I am labeling them like that for a reason, so that you understand that you can use this every single time. Okay? So for the sine function, you start at 0, you go up to the max, halfway is 0, down to the min, and then you end at your period. So this is one cycle. Okay? This is your one cycle. Now briefly we talked about reflections yesterday, okay, and you did have a reflection one on your homework. So if you have a reflection, remember, that's the opposite. So when you apply a negative to 0, it stays 0, right? If you apply a negative to the max, what does it become? The what? The min. So if you have a reflection, instead of going up to the max, down to the min, you'd start by going down to the min and then up to the max. Okay? Alright, now for this one in particular, we're going to follow the same type of pattern. Okay? So we're going to start at 0. This is your start. And when you start at 0, your ending point is at 0. And you guys can use a pencil. I'm just using this so that you can see it better. Alright, so you start at 0, you end at the period. So what is the period for this case? You need to look back up. Yep, period is 0.002. Okay, so at 0.002, I am at 0. Okay? So all we have to do now is we start here, we end at 0.002. So remember, start at 0, end at 0, and then halfway, where are we? At 0. So you can just count your units as well. Okay? So if this is 4 units, halfway is 2 units, right? And that occurs at 0.001. Okay? That's your halfway mark. Okay? And then what's going to happen here at this one? This is going to end up being our, no, max. Do the max and then the min unless there's a reflection. Okay, what is our maximum? 3. What's our minimum? -3. Okay, and you can just look at that on your graph. Okay, and then let's label. So this is your 3. This is your -3. Okay, so I'm going to go up to 3 and then down to -3. This is my one cycle here. Okay, and then I have this labeled as 0.0005. Okay, and then, so if you're going by 5 one time, see how this is 5, 1, 2? So this next one is 1.5. So it's 0.0015. So I like to think of this as 5, 10, 15, 20, with the zeros on the end. Okay? Or 0.5, 1, 1.5, 2. And then you just have to keep repeating the pattern. Okay? So once you're at 0, you go over 1 to the max, over 1 to 0, over 1 to the min, over 1 to 0, okay, and then over 1 to the max again. Okay, and that's your graph. So again, remember, for this one you don't have to do the negative only because it's a real world model. For all the other ones that you have, you'll do the full scale, okay? Alright, so that was a continuation of yesterday. The next part that we're doing is going to take what we did yesterday, and we are going to do different, what's called phase shifts, and then eventually we will get to vertical shifts as well. So a phase shift is a horizontal translation. If you look at these two examples, they look similar to the transformations that we did in the earlier chapters. So if you have the K units, okay, that is going to be something that moves the graph up or down. Okay, but what we're going to focus on today is a phase shift, and that is going to be the horizontal translation. It's going to move the graph left or right. Okay, so this is a horizontal translation. Okay, and then just remember that that is going to move your graph left or right. Okay, so a phase shift of H units moves the graph left or right. So here are your cases. Okay, if H is positive, okay, you're going to move this to the right. If H is negative, you're going to move to the left. Okay, and that is the same thing that we had when we were doing horizontal transformations. Now, when you're doing the shift with trig functions, you can combine the transformations. And we're going to use this to help us identify where important features of the sine and cosine graphs are. So for example, A, remember what this outside is going to tell you? It is a vertical structure compression. It's also the same thing as what on the graph? Yes, which is the word starts with an A. Amplitude. Everything you guys said was true though. The amplitude does affect the vertical stretch and vertical compression, and it does directly relate to your max and your min. Okay, do you guys remember what B is going to affect? Yeah, and so it's going to affect your period. Yep, so it is going to be the horizontal structure compression. It's directly related to the period of your graph. Okay, now this H, it is the same thing as a horizontal translation, but this is what we are referring to as the phase shift. Okay, so that is going to be our focus today, is this phase shift. Okay, and then the plus K is the same as before. We call that a vertical shift. Okay, so that moves the graph up and down. This moves the graph left or right. Okay, the reason why we're focusing on the phase shift today is because when we're moving things left or right now, we're going to be moving them in radian values. Okay, and so that can be a little bit different. So I put together like a step-by-step, like, hey, you can go through these steps. Once we've identified some of these in the notes today, you're going to be able to use this on your homework problems. All right? So we're going to graph the function. We also have to identify the x-intercepts and the phase shift. Okay, and for A, your function is g of x equals the sine of x minus 4. Okay, so this is what we are graphing today. So the first thing we're going to do is identify the amplitude and the period. So this will probably be the simplest part. Because the amplitude is always hanging out where? Yes, in front. And if you don't see anything, like here's your A value, do we have anything there? Yeah, so if you can't see it, it's a 1. Absolute value of A is 1, so your amplitude is 1. Okay, do you guys remember the formula to find the period? B. 2 pi over B. And then what's our B in this case? No? 1. Why? Where does B hang out? Yes. Okay, so the B hangs out here. Okay, so if you can't see it, remember, it is a 1. Okay, so the period is 2 pi. Alright, now we are going to identify the phase shift. So we have to identify the H value. The H value can be positive or negative. Remember that in the formula, in front of H is a minus sign, which means that you do the opposite of what you see. So if it's x minus pi over 4, the H value is pi over 4. Okay? So the phase shift is pi over 4 radians to the right. Pi over 4 radians to the right. Okay, so that means what we're finding in just a minute, we're going to have to take the x-intercepts, the maxima, the minima, all of them are shifted pi over 4 units to the right. Now, when you are shifting them to the right, you add, okay? So we're going to be adding because it is to the right. We're going to be adding the phase shift. And then I call this PS for phase shift. Okay? And then we're just going to make a little note, okay? Note in phase shift, so PS is to the left, you subtract. Okay, so your homework will be a mix of both. So if it's to the right, you're going to add. If the phase shift is to the left, you're going to subtract. Alright, so the first thing that we're going to do when we are identifying the x-intercepts is we have to look at the graph of the sign of x. Okay, you have a really nice graph in your characteristics chart from your notes yesterday, so if you want to look at that, you can. We're also just going to draw like a rough sketch here. Okay, because when you have the sign, remember, you start at 0, 0, you end at 2 pi, and what's halfway in between? Pi. What's halfway between 0 and pi? Pi over 2. Halfway in between here is 3 pi over 2. Okay, so at pi over 2, you go up to your max, here you go down to your min. Okay, so that's your one cycle for sine, okay? That is something that you will commit to memory, okay? And it's something that you should be using over and over in order to help you graph, okay? So, where's the first x-intercept? So what we have to do is use the graph of sine of x and apply the phase shift, okay? So if we're looking at the graph of sine of x, where is the first x-intercept here? 0. Okay, so it's 0 plus pi over 4. Okay, so that's just going to be pi over 4. For sine, yes. So for sine, you can always use 0, okay? Always use 0 and then apply your phase shift. So pi over 4 is the phase shift, okay? So the pi over 4 is what's going to change from problem to problem. 0 will not. And then you have your very first at positive pi over 4, okay? Now, when you are identifying the x-intercepts, you are finding all of the x-intercepts. So if you look at this graph, the x-intercepts occur every how many units? So let's look. Here's the first one at 0. Where's the next x-intercept? No. There's one before it. There is one at pi over 2. Where else? No, the x-intercept. But where else is it 0? Yeah. At what point? At pi. So see, it's 0 pi, pi over 2. Okay, so for our graph, right? And then please get out your notes from yesterday too. And go to page 2. Okay, so when you are looking at this, okay, see how you have your first x-intercept here at 0? Where's the next time it crosses the x-axis? Pi. Then it crosses here at 2 pi. Where's the next one going to be? 3 pi. And then after that it will be 4 pi, 5 pi, 6 pi. So they occur every how many units? 1 what? Pi. 1 pi. Okay, so the x-intercepts occur every pi units for the sine of x. So that is going to affect our answer, but like I said, now that we've done this, we're going to do that every single time. So the way that we would write our final answer is pi over 4 plus pi n, because they occur every how many units? Pi. Okay? Do you guys remember what n represents? Do you guys remember what n represents? More specific? No? Integer. Yes, good. Okay, so it can be any integer. Do you guys remember the last time we used like a plus? It wasn't pi n. Do you guys remember what it was?
Oh, 2 pi n.
2 pi n. Yeah, okay. Do you guys remember why we were adding 2 pi n to things?
Just like all the previous one cycle.
Yeah, it was your one cycle because we did one revolution, right? Okay, so every pi n means we can go every pi unit, correct? Okay, so if I'm at pi over 4 and I add pi to it, where would my next? This is the first x-intercept. Where would my next one be? Yes, how'd you get it? Yes, just add pi over 4 plus pi, right? So you have to think of like, okay, if these have the same denominator, this is 4 pi over 4, right? So that's how you get 5 pi over 4. Okay, so this is your second x-intercept. So when we graph, we'll verify that, okay? And then if you want to find the next one, you could just add pi again, and you could find your x-intercepts. So they occur every pi. So if they occur every pi units, if this is the first one, add pi to find the second one, you can keep going, all right? You could also subtract because it could be a negative number as well. All right, so now we're going to talk about the maximum and the minimum values. So when you are finding the max and the min, again, we're going to go back to that original graph, and we're going to use the sign of x and apply the phase shift, okay? All right, so for the x-intercepts, the max of the sign of x, where does it occur? on the x-axis. Occurs at what value? On the x. So here's at pi over 2. So at pi over 2 I hit the max, right? Okay, so if I hit the max at pi over 2, all I have to do is take that value and apply the phase shift. So pi over 2 plus pi over 4. Again, you're adding pi over 4 because that is the phase shift. Alright, so we can get common denominators. What would our common denominator be for this one? 4. So pi over 4 would stay. Pi over 2 would become what?
2 pi over 4.
Yes. And then really we're just adding these like fractions. 2 pi plus pi is?
2 pi over 4.
Yeah. Okay, so then the first thing that you have is the maxima occur at 3 pi over 4 plus 2 pi n. Now remember, before it was at pi n, the maxima and the minima are going to be 2 pi n, and that's because they occur once every 2 pi. They only occur once every cycle. That's why you have the 2 pi n. Okay? So once every period. And they have a value of 1. Okay, so your 2 pi is your period. Okay, so I want you guys to try to do the min. So we're going to set it up the same way. So the min of sine of x occurs at, fill that in, and let's find that. And you guys already know what the value is, right? What's the min value? The,
Yeah.
you do it. So where does the min happen? Okay, so again, just look at your chart here. So you have 3 pi over 2, which is where you have the min. And then what do we have to add to 3 pi over 2?
Pi over 4.
Yes. So 3 pi over 2 plus pi over 4. Again, we're using pi over 4 because that's your phase shift. So that's going to change from problem to problem. You know what's not going to change? Where the max is, where the min is. Okay? So the thing that's going to be changing is your phase shift. So again, just get a common denominator. It's still 4, so times 2 times 2, 6 pi over 4 plus pi over 4 is 7 pi over 4. Okay, so then the minima occur at 7 pi over 4 plus 2 pi n and have a value of -1. Okay, now, for this one, we're going to graph all of this using the information. We're not going to be using our graphing calculator, and you're just going to have to trust me that it's easier without it. Okay, so I'm gonna help you with that. Again, it's all about the pattern. We are going to label 5 points in a table, and we are going to label our graph. Now, before, when we were labeling our graph, it was easier to do the period divided by 4. Okay, for phase shifts, your x scale should be your phase shift, because that's going to make things a lot easier. So remember how our phase shift was pi over 4? Okay, so each one is going to be pi over 4. Okay? But label this with me, and then we're going to go back through this. So if I do 1 pi over 4, then here I'm at 2 pi over 4, which is pi over 2. Okay? If I make every 1 pi over 4, we end up getting this standard scale here, which I'm going to show you. And we're going to do the negative side. And then you can decide where you want the 1 to be. For me, I like to put my 1 here, I think it's easier for me to make the curves when I scale the y by halves, but that does not matter. So you can do the halves, you can do Alright, so remember I said we do want to go by our phase shift, our pi over 4. Okay, we have done that. So on the right side, I'm going to show you how we've been doing that. So this is 1 pi over 4. What is 2 pi over 4 reduced to? 1 pi over 2, right? So that's what we have. So this is 1 pi over 4, 2 pi over 4. Guess what this guy is? 3 pi over 4. We have 4 pi over 4, 5 pi over 4, 6 pi over 4, which reduced, 7 pi over 4, 8 pi over 4, and we're going to end with 9 pi over 4. Okay, you don't have to do that on this side. I know it gets crowded. I just want you to understand the counting, and this is going to help us with our pattern, okay? So when you're doing your tables, and this goes for last night too, you should be setting them up in a way that's similar to what I'm doing. So it's x and then g of x, because our original problem is g of x equals the sine of x minus pi over 4. Okay? When you have sine, you normally start at 0, but now our 0 point has shifted. So when you do this, for sine, I want you to start at the phase shift. So what was our phase shift? Pi over 4. Okay? Now, for sine, if you start at the phase shift, guess what your value, your output value is? 0, because wasn't that what it was before? 0. And if you aren't sure, remember, you can just plug that in. Your equation is g of x equals the sine of x minus pi over 4. So if you plug in pi over 4, what's pi over 4 minus pi over 4? 0. How can I find the sine of 0 without my calculator? On the unit circle, right? 1, 0. So my y coordinate at 0 is 0. Yay. So when you're starting at your phase shift, okay, that is where your first point is going to go. Yes. Okay, and then we can put our first point on there. It's pi 0. Now, after we do the start, we go to the end. Do you guys remember where the end was before? So we started at 0. Where do we end? Yeah, for sine we did 2 pi. Why did we do 2 pi? That's a full period. So the end is still going to be a full period. So all we have to do is the phase shift plus the period. That's going to be where you end. Okay, so the end is the phase shift plus your period. Okay, so what was our period? 2 pi, so 2 pi plus pi over 4. What's that going to be? Yep, 9 pi over 4. right? Because 2 pi is like 8 pi over 4, and then 8 plus 1. So guess what? If I start at pi over 4 and I get 0, I end at 0. And then what do we usually do for sign? We do the start, we do the end. What's the next point I graph? Half. And to do halfway, all you have to do is count the units. 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4 is halfway. And it's at 0. Now, remember, didn't we come up with an equation for the x-intercepts? Yes, we did. Where did we say the first x-intercept was going to be? So the first one was at pi over 4. What did we calculate the second one to be? Minus pi over 4. Is that what we have? Yep. Okay. Now, what happens halfway in between these two? Goes to my max. What's my max? My max is 1. Yep. And it is at 3 pi over 4. And again, I labeled that. So that's all I need to do is 3 pi over 4 is at my max. And then I can count 2, go to my min. I have that labeled. That's 7 pi over 4. And that's at my minimum. And now I have one cycle, and I have a pattern that I can just continue to repeat. Okay, so if in this direction you go 1, 2 up, in the opposite direction you go 1, 2 down. Then you go 1, 2, 0, 1, 2 up, 1, 2, 0, 1, 2 down. And remember, you do have to connect these with a curve. You can see I like to do one cycle at a time. That's when I do my best work. And that's your graph. We did it. Okay, now we're going to do very similar things, but this is going to be for cosine. Okay, the next one's going to be for cosine. So we have g of x equals the cosine of x minus pi. Alright, so your amplitude for this is what? 1. What's the period? 2 pi. Okay, again, because you have the 1 in front and the 1 in front. So 2 pi over 1, 2 pi over b. Okay? Identify your phase shift. So is your h value going to be positive or negative? Positive, because if you see the minus here, it's the opposite. So this is another one where you're going pi radians to the right. Okay, so that means all of your x-intercepts, your max, your mins, they are all shifted. Oh, this says of f of x, I should say g of x. They are shifted pi units to the right. And if we're going to the right, that means we're doing what? We're adding. Okay, so we're going to add. Okay, and then if h is negative, that's when you subtract. Now, when you are thinking of the x-intercepts, okay, we're going to look at the cosine. We're going to look at the cosine graph. Okay, but cosine's a little bit different because remember how it starts at the min? So I want you to leave some room on this side. Okay. This is another great time to reference your characteristics chart because your max is 1, your negative is 1. You start here at the max. At 2 pi, you end at the max. At pi, you are at your min, and then halfway between at pi over 2 and at 3 pi over 2. That's where you have your values. I also have that on the board for you, on the front board. So the first x-intercept, if you are looking at your x-intercepts, the cosine, just like the sine, okay, occurs every pi units. So the x-intercepts occur every pi units. That is the same for both cosine and sine. So if they both occur every pi units, that means when you find your x-intercepts, you are going to put plus pi n at the end, okay? All right, now I want us to look at our graph, and the x-intercepts that you can see on the positive side are pi over 2 and 3 pi over 2. Okay, but if you have your characteristics chart in front of you, where is the first negative intercept? The first negative x-intercept. It's here at negative pi over 2. Okay, so this is the one that we have to use to shift, and I'll show you why. Okay, again, once we've done this together, you are good. So if you were to take pi over 2 and add the phase shift of pi, okay, you guys would get 3 pi over 2. Okay, remember, 3 pi over 2 is all the way down here, so there likely is an intercept that's above it, and you know it because these occur every pi units. Do you guys know what 3 pi over 2 minus pi is? Pi over 2. So look, when you take negative pi over 2 and add pi, you get pi over 2. Which one comes first? Pi over 2. So this one is the first x-intercept. This one is the second x-intercept. Now that is naturally going to come out when you are graphing. So if you want to graph first and then go back and put in the pi over 2, that is perfectly fine. Okay, but these are going to be where your x-intercepts are. Every pi n, the first one's at pi over 2. Okay, the max and min values, the maximum and mins, they still occur between the x-intercepts. So all we have to do is think of the cosine of x. The max value occurs at 0. So just like we did before, we're just going to take 0 and then we're going to add the phase shift. So our phase shift for this one is what? Our phase shift for this one is pi. So 0 plus pi is pi. Okay, so wherever the max value occurs, you're just going to add the phase shift. So the maxima occur at pi plus 2 pi n, okay, because this is the period. And then they have a value of 1 because it's going to match the amplitude, okay? Alright, now let's look at the minima. So where is the first minima on cosine? Yeah, I heard it. Where? Pi. The min value occurs at pi. So then all we have to do is take pi plus pi, which is 2 pi, okay? Now, if it's 2 pi and it occurs every pi, you could also think of it as there's another minimum value that happens at pi. Okay, so you could also do negative pi plus pi, which is 0. You could just do 2 pi minus 2 pi. For this, I really would accept either one. So you could either do 0 plus 2 pi n, which is the preferred one because it's the lowest positive value. What's 0 plus 2 pi n though? 2 pi n. Okay. And this is your first positive value. 2 pi plus 2 pi n, I would also accept that, okay? So I would accept 2 pi n, or I would accept 2 pi plus 2 pi n. I would accept either one for this, okay? Alright, so now we're just going to graph using our pattern, okay? Now, what's that? Oh, first positive value. So just the first value on the positive side is this one. This would be the next positive value. Alright, so, yeah, for this one, let's do our table, and then, let's do our table, and then we'll finish that tomorrow. And then tomorrow, also remember, is a work day, unless you are making up your quiz.